quality down, but I'm up, Miss Jens. That's what I'm talking about. 1.13, removing discontinuities. Alright. What is a removable discontinuity? That is a hole. A hole in a hole only, Mr. Jensen. Limit of f of x as x approaches c exists, but f of x as x approaches c cannot equal f of c. That's just saying that it can approach, let's just say x approaches 1, right? F of x cannot equal 1. It can never equal the point. It can approach it, but it can't equal the point. That is all that is saying. Alright. Now, number 1. F of x. We know that the value of the whole is 1 because when we factor x squared minus 1, we get x minus 1 times x plus 1 over x minus 1. So that at x equals 1, there is, in fact, a whole. And that x cannot equal 1. How do we find the y value? Very simple. This is the equation that's left, is f of x equals x plus 1. We plug in 1, the y value we get is 2. So, at f of x, we know that at x squared minus 1 over x minus 1, x cannot equal 1. And at 2, where f of x equals 2, x equals 1. If the function f is continuous for all real numbers, and if f of x equals x squared plus 6x plus 8 over x plus 4, when x does not equal negative 4, x cannot equal negative 4, then f of negative 4 equals negative 2. And I'll show you how I got that. I did, when you factor that x squared plus 6x plus 8, you get x plus 4 over, or x plus 4 times x plus 2 over x plus 4. So that cancels out and that's the whole. So we're removing the discontinuity. And we're plugging in negative 4. So f of x equals negative 4 plus 2. So f of negative 4 equals negative 2. So f of x, when f of x is x squared plus 6x plus 8 over x plus 4, x cannot equal negative 4. But when f of x equals negative 2, x equals negative 4. So that's just saying, like, they approach to the same point, but there's a hole and the point is actually up here or in a different spot than where it approaches. So let f be the function defined by x squared minus 3x minus 18 over x minus 6. X cannot equal 6, but at a, x equals 6. So for what value of a is f continuous at x equals 6? So we're working backwards here. We factor it, we take out the whole at x equals 6, and we get x plus 3. And we know that when we plug in x equals 6 to this equation, we get 9. So a must equal 9.